Yeah, welcome you all for another beautiful presentation on signals and systems. So, since last presentations, we have continuously been seeing the various topics in signals and systems subject, and we have discussed what is a signal and what are the types of signals we have seen. And in last presentation, we have told to you that there are certain elementary or standard type of signals are also there, which are normally used in the system in order to study the behavior of a signal. So, out of the standard or elementary classifications of signal, the first and foremost is the unit impulse function. This is one unit impulse or unit impulse signal or function, whatever way you can call. So the unit impulse function or unit impulse signal. What is a impulse signal? So impulse signal is denoted by the letter delta of t. This is in continuous time signal. So this unit impulse signal can be defined in both the cases, both in a continuous time signal as well as this can be defined for discrete time also. If we define the impulse signal or unit impulse signal for continuous time, then you have to represent this delta of t. This can be read as delta of t, and the definition equal to delta of t is equal to, you can say, actually in 1 for t equal to 0, and it is equal to 0 for t is not equal to 0. That is the definition of unit impulse. Why unit actually? In fact, if you say impulse signal, if you exactly give the definition of this impulse signal, normally the impulse signal definition is in general delta of t is equal to infinite. Actually, it's not 1, for it is same t equal to 0. This will not change, and it is 0 for t is not equal to 0. This is the exact definition of the impulse signal. This is for impulse signal. This is the definition for impulse signal. Impulse signal. So delta of t is equal to infinite, means at t equal to 0, if you see at t equal to 0, the delta of t value or the magnitude of delta of t goes to infinite, and for other than 0 values of time, that is delta t value is 0. Clear? So whereas unit impulse means the magnitude value will be 1, because with this definition you can't solve any problem actually. So if delta t is equal to infinite, if the magnitude goes to infinity, it going on, it goes on. So normally it will be not used. So it is not possible to use the application of this delta function in the problem solving. That's why, so we must have certain value of this. Instead of infinite, delta of t should have one value. That's why we are taking unit impulse. That's why now instead of infinite, we are considering as 1 for the same time intervals. Clear? Okay, I think you understood this. Okay, and otherwise in a graphical representation of this unit impulse can be shown as like this. So graphically, I will erase this. Graphically you can show this. Graphically, delta of t can be shown as follows. How? It is time versus, if you take axis like this is the time axis. This you can take time, continuous time t, whereas this is your magnitude delta of t value. If you take, this is time, no, therefore this is what initially t equal to 0 actually. This is 0 and this is 1, this is 2, 3, 4, 5 seconds, you can say seconds, 5 seconds, 6 seconds, 7, like that. And if you take, it is -1, -2, -3, and so on and so forth, -4 and then -5 and so on. So it goes like that. So actually if you consider delta t is equal to infinite for t equal to 0 and equal to 0 for t is not equal to 0. If you consider this particular definition, means impulse, this is what impulse function, actual definition. So means that at t equal to 0, means this is the t equal to 0 point. Here, what is the delta t value? It goes on infinite, like this. It goes off infinity, but here it shows arrow mark upward direction, like this. If you see, this shows, okay, little bit thicker you have to show, little bit thicker line, means at t is equal to, this is t equal to 0 point actually. At t equal to 0, your delta of t is upward direction, it is going actually, means it is infinite value. It is infinite value, is it not? At t equal to 0 only. So other than t not equal to 0 means other than 0 means at all other values of t, means 1, 2, 3, 4, 5. If you take on plus value, plus side, as well as if you take -1, -2 on the left side, at all these remaining values, its value is 0. So you will not have any delta of t value. So 0 here. That's it. It will be like this. So as it is 0, there is nothing, it gives no sense actually. So therefore, at this particular point only, the value of delta t is defined, and it is represented like this. Arrow mark indicates that it is infinite value at t equal to 0 itself, only at t equal to 0. By that way, you can remember one important point. The width of this impulse signal is 0. There is no width actually, because at t equal to 0 itself, it is available at t equal to 0 like this. Therefore, it has 0 width. There is no width. Okay, so the width is 0 here for this impulse function. This is actually for impulse function. Now, I am considering as unit impulse. So instead of infinite, if you take a impulse signal as unit impulse, for unit impulse, simply you write 1 only. You can write delta of t value is 1. That if you take 1, then impulse signal or impulse function becomes as unit impulse. Then instead of arrow mark, you simply represent as like this. One particular, you can write arrow mark, no problem, but here the magnitude is 1. Or simply you can represent like this. Okay, so here the magnitude value, delta of t value is 1. So it is limited to 1 itself. Again, the width is 0 here also, and at t equal to 0, the delta of t is 1, and for all other values of time, it is 0. That is what unit impulse function. Very, very important, unit impulse function. And one of the very, very important property of this unit impulse function is that if you take the area under that graph actually, okay, that is very, very important property, that is equal to -infinity to +infinite delta of t dt is equal to 1. Very, very useful property, very important property of unit impulse function. So integral over -infinite to +infinite delta of t, it means that integral nothing but you are estimating, you are calculating the area. If you take the integration means you are considering the total area under that graph actually, total area under that graph. What is graph? This graph actually. We have considered this value, no? This value. So here, so this particular. So under this area, under this graph, what is the total area? That area should be 1. The total area under the curve is equal to 1. This is very, very important property of impulse function. Integral over -infinity to +infinite delta of t dt is equal to 1. Clear? This is what very, very important property. and there are some more important properties are there that I can explain you now. And one more important thing to remember or to note is that remember that any signal remember any signal like your x of t or y of t, any other signal like x of t and y of t, etc. Any signal multiplied with, okay, any signal multiplied with your impulse function delta of t gives the actual signal only. This is very, very important, because delta of t, wherever the impulse function delta of t comes, you will take that value is 1, and the time limitation will be considered at t equal to 0. This is defined at t equal to 0, and at t equal to 0 its value is 1. So 1 is multiplied with x of t or y of t. 1 into x of t is x of t itself. Clear? What I mean to say is that if x of t is there, x of t is multiplied by delta of t, then what you will get, you will get your x of t itself only, x of t, where what is delta of t? Delta of t is defined at t equal to 0, therefore this value also, so if you multiply like this, you will get x of t. In this x of t, you substitute t equal to 0 of delta of t, means obviously you will get x of t only. This is what actually x of t multiplied with impulse function gives rise to your actual signal only. That we will see with some properties, so that you will understand this. I will explain you that. And one more thing that I want to explain here is that I will show you. There is another property basically. So integral, this is another important property actually. Integral minus infinity to plus infinite, it is x of t into delta of t dt is equal to, you will get x of 0. This is another important property of unit impulse function or unit impulse signal. Minus infinity to plus infinity, x of t into delta of t equal dt is equal to x of 0. This is what? The same, whatever I just explained you, the same actually. If you take the area of this multiplied quantity, x of t is multiplied with unit impulse, obviously we will get your input signal only, I mean actual input signal only, where in this input signal, so in place of the time t, you must substitute here this t value of delta t. So at what time of t delta t is available, that time value you must substitute in the input signal. Clear? So based on, you will expect some important questions. If you solve some questions, then you will understand very clearly. I think here nothing too difficult to understand. X of t multiplied with delta of t, then your x of t will come. Again in this x of t, the t, whatever is there, this is actually t, x of t in general, where t is substituted as 0. Why we have applied 0? At t equal to 0, your delta of t value is 1. At t equal to 0, what is my delta of t value? It is 1. Therefore, 1 is multiplied by x of t. So, at what time the delta is available, that time you have to substitute here. That is the meaning of this particular. Clear? And similarly, the similar kind of property is there. One more property based on this only. The similar, it is nothing new thing. Actually, it is relevant to that minus infinity to plus infinity. And then say for example, x of t into delta of t minus t naught, let us say. T minus t naught, let us say, is equal to, what is this actually, x of, tell me, t naught. This is your answer. So, in this case, what I am doing actually, x of t is our actual signal, input signal. Delta of t minus t naught. What is this? Delta of t is unit impulse. What is t minus t naught? It is a shifted impulse function. It is a shifted, it is called time shifted. It is shifted unit impulse function. Shifted unit impulse function. What is shifted? Your time is shifted. T minus t naught equal to 0. For example, t equal to t naught means the time is shifted by the another some constant, that is t naught. Means that, is it not? So t minus t naught, this is called a shifted impulse function. Shifted impulse function. So by what amount that impulse function is shifted? By t naught amount. By t naught amount, the unit impulse function is shifted. Therefore, if the shifted unit impulse function is multiplied with x of t, then definitely you should get your actual input signal itself, and in that signal, instead of t, you must substitute the value of what is the amount of shifted. That shifted value you must apply, you must substitute in your x of t. What is the shifted value? T naught. T is equal to T naught. T naught is the shifted, this much, units, this signal was shifted. Therefore, at T equal to T naught, therefore, in x of t, you substitute, instead of t, you substitute T naught. That is your answer. Clear? That is what another important property of unit impulse function. Very, very important. So normally, these are very, very important, especially in GATE point of view. In GATE examinations, you will be asked this. And another important property is delta of scaling property. This is called scaling property. Scaling property of unit impulse function. It is delta of AT is equal to 1 by magnitude of A into delta of t. This is another important property of unit impulse function. Clear? Delta of t is equal to 1 by A. What is A actually? Delta of t is a actual impulse function. That time period is multiplied with some constant A, that is called a scaling constant. If you multiply with constant A with time, this is called scaling constant or scaling parameter. You can call it as scaling constant. That's why it is called, this property is called as a scaling property of unit impulse. So if impulse function is multiplied, not unit impulse, the time is multiplied with some constant A into t, then if you take this is equivalent to 1 by A of delta t. 1 by A of delta t. Clear? This is one important property. So far we have seen the unit impulse with the continuous time signal. So for example, the same is applicable for discrete time also. In discrete time, otherwise for discrete time, so the unit impulse function is defined as delta of n, where you can write delta of n actually. In continuous time, delta of t, we have to note down like that. So for discrete time, we have to represent, and it is defined as delta of n. Delta of n is equal to 1 for same, n equal to and 0. This is n is the discrete time, and it is 0 for n is not equal to 0. This is the definition of unit impulse function for discrete time actually. Same as previous. Instead of delta of t, I am taking it as n. N is the discrete time actually. N is the discrete time. Therefore, delta of n is equal to 1 for n equal to 0, and it is 0 for n is not equal to 0. Clear? And similarly, that area under the delta of n, how you can represent the area under the curve or graph, whatever it is. As it is a discrete, in a discrete, you must write the summation sigma n is equal to minus infinity to plus infinity delta of n is equal to 1. This is for discrete time signal. So whereas for continuous time, we will consider the integration. Integration will be used for continuous time signals, whereas for discrete time signals, instead of integral, you will write the summation summation. This is called summation, or otherwise also called as sigma. Sigma n is equal to means discrete time minus infinity to plus infinite. Delta of n is equal to 1. Clear? And remaining property, whatever we have seen, all are similar in discrete, all are valid for a discrete time also. Instead of integral, we will consider as sigma only. There is nothing new in this. Okay, so shall we see one example, and then you will understand better. Actually, we'll solve one example based on this example. Evaluate the following integrals. Evaluate the following integrals, because on continuous time some examples are there. We will see at least one example now. So this is integral over minus infinity to plus infinite. It is given e power minus a into t square delta of t minus 5 into dt. Evaluate this integral. This is the given integral. How we can, what is the value, what is the answer for this, how we can solve this? Minus infinity to plus infinity e power minus a t square into delta of t minus 5 into dt. So if you observe carefully, this is actually your x of t. E power minus a t square is your x of t. Okay, the solution part. So what is your x of t actually? X of t is nothing but, here if you compare with our standard, x of t is equal to e power minus a t square is nothing but your x of t. Then what is this delta of t minus 5? What is this? It is a shifted impulse function. It is a shifted impulse function. Therefore, by what amount this impulse function was shifted? T is equal to 5. By saying this, you can say that it is a shifted impulse function and t is equal to 5 units, because delta of t minus 5 is equal to 1. Clear? From the definition of the impulse function. So, some delta of t is equal to 1 for t is equal to 0 in general. In general, the definition of impulse function is equal to delta of t. If you consider delta of t is equal to 1 for t equal to 0. But here for the shifted, delta of t minus 5 is equal to 1 for t is equal to 5. For t is equal to 5, if you substitute t is equal to 5 here, 5 minus 5, 0 means your t value becomes 0, no? If you substitute here 5 minus 5, 0 means t value, time value becomes 0. At time t equal to 0, this shifted value becomes 1. And it is 0 for otherwise. Therefore, from the shifted value of impulse function, t is equal to 5. Now, this t value you must substitute here. This is equal to your x of t is equal to e power minus a into what is t value? 5 square. And this is equal to e power minus 25 into a. That's it. That is the answer for this integration. Understood? Very simple to understand. I think it is better to finish off this presentation here, and we will see some more interesting examples on this impulse function, and some questions which were asked in previous GATE examinations also. And very important topic this is, as far as your GATE is concerned, and very easy, very simple to understand and to exercise the problems also. Okay, so I think we'll finish off here, and we will meet in the next subsequent presentation. Okay, have a nice day. See you.